Okay. If we write the equation of motion, we have 2m like this one. If we want to collect all the terms in a state space formation, and so x1 dot dot and x2 dot dot should be written in terms of the states. Okay, and so what about this one? If we pull and organize a whole equation, we will get this one, x1 term minus k2 divided by m1 minus k1 divided by m1 plus x2 k2 m1 plus x1 dot minus c2 m1 minus c1 m1, and also we have x2 dot, and x2 dot is derived from the what to this one in here, and so the c2 m1. Okay, and also this is the first equation, and the second equation, x2 dot dot is equals to the what? This is not a minus, guys. This is the 1, this is the 2. Okay, in this case we need to write the first term, x1 k2 divided by m2 plus x2 minus k2 divided by m2 plus x1 dot, this is c2 divided by m2 plus x2 dot minus c2 m2 plus f divided by m2. This is the organized form of the what? The x1 dot dot and x2 dot dot. Okay, that's it. So in the other form we have this one just like this one. In SS form we get z1 is equals to the what? x1, and z2 is equals to x2. z3 is equals to the x1 dot, and z4 is equals to the x2 dot. Okay, this is our selection or the choice. You can design anything based on these terms. Okay, and so what's the values of the z1 dot? Correct? No, z3. And what is the values of the z2 dot? z4. And what is the values of the z3 dot? This is the x1 dot, and which means that this is equals to what? x1 dot dot, right? And so z1 times minus k plus k2 m1, and z2 times k2 divided by m1 plus z3 times minus c1 c2 m1 plus z4 c2 divided by m1. How can we obtain this z3 dot equation? Just see that is coming from this one. Okay, nothing more. Okay, and so what about this one? z4 dot. This is z1 k2 divided by m2 plus z2 minus k2 divided by m2, and plus z3 times c2 m2 plus z4 minus c2 m2, and plus f divided by m2. Where is it coming from? This is coming from the second equation. Okay, So, how can we write the state space equation in here? First of all, just write this one, z dot, which is equals to the a z plus b u, and where z is equals to the what? Z1, Z2, Z3, Z4 transpose, right? And what is it u? Yes, that's all. F. Okay, nothing more. Okay, and so how can we write A and B in here? Z1 dot, Z2 dot, Z3 dot, and Z4 dot, right? We should write the A matrix, right? And so how can we do that? First of all, Z1 dot, which is equals to the what? 0 or 0, 1, and 0, right? Like these terms, 0, 1, 0. But with the multiplication of the what? Z1, Z2, and Z3, and Z4, right? Where is it coming from? It's coming from this one, this equation, okay? And so Z dot 2, what is Z dot 2? In the second row, Z4, and so 0, 0, 0, 1, okay? And so what about the Z3 dot? Just tell me, what's the first element? Yeah, M1, and so second, K2, yes, third, yeah, last, yes, M1. And so what about the last row? K2, M2, second, minus K2, M2, yes, last, minus C2, M2, okay, plus, we have also a fourth term in here. First one, second, third, last, yes. This is the state space representation. Okay? Any question? Okay. So, this is the first part of our study for today. But in the second part, we need to know how we can convert transfer function to state space. This can be done, but just giving the formula. Consider the differential equation. Yes, what is the meaning of the differential equation? Huh? Yes, yes, that's it. Just say it. A1 dy dt, which is equals to the what? I'm sorry, we have also one more term. A0 times y, which is equals to what? B0 times u. This is the general form of the differential equation, NTH order. Okay? Okay? So, how can we define the state space from it? Just remember the dummy variable, right? In order to represent assess. First of all, x1 is a dummy variable. We can assign the y. x2 can be assigned with what? Y dot. x3 second order derivative, and xn is equals to the what? dn minus 1 y dtn minus 1, right? So if we take the derivative of this term, x1 dot, which is equals to the what in this case? Yes, x2 dot. Yes, and blah blah blah, xn minus 1 dot, which is equals to the what? Yes, plus 1, right? But in order to remove this plus 1, we should write this one, minus 1. Okay, that's it. So we need to turn into the what to this equation. This is the xn, and so we can write this xn just like this one. This yields xn dot, which is equals to what? Minus a0 x1 minus a1 x2, because this is the xn dot, right? And so every term is put in the right hand side, we will get it, because a0y is transferring to the right hand side. This is a minus xn dot, right, which is equals to what? Minus a0 times x1 minus a1 x2. What is the x2? This is the x2, right? Yani sağ tarafa atınca bu denklem oluyor. Eksi blah 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 and minus an minus xn plus b0u, because this is the positive and it's at the right hand side. Okay, and so how can we write the state space form? X dot is equals to the ax plus bu in here. Just help me. Yes. And so we have this vector x1 dot, x2 dot, blah 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 blah, and xn minus dot, xn dot, right? And which is equals to the what? We have the matrices in here just like this one, and also we have the what? x1, x2, blah 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 blah, xn minus 1 and xn, right? Yes. How can we write this equation? x1 dot, which is equals to the what? x1 dot, x2. And so first term is 0, second is 1, and rest of them is what? 0, right? What about the x2 dot? x2 dot is equals to the what? Yes, and x1 0, x2 0, and goes on this one. What about the last one? And so this is 0 0, the same pattern happens in here, and xn minus 1 dot, and 0 0 0 blah 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 0, and xn minus xn, right? And so this is 1. What about the xn dot? Yes? Huh? Yes, minus a0 minus a1 blah 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 until to the what? Minus an2 minus an1, right? This coming from this term. And so what about the input vector or input matrix in here? This is multiplied with a u, right? And so x1 dot has or possess the u or not? x1 dot. No, and so 0, 0, 0, blah, 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 0. And the last term has? Yes, B0. That's all. This is called the fast variable form, guys. That's it. Okay? So, in order to understand this concept, we need to what? We need to solve the example. Okay. So, example. Suppose that we have transfer function like this one, ys for a given us, which is equals to what? 5 s square 3s plus 2. Okay, the us is given with the plant and this generates the ys. Okay, s square 3s plus 2. Okay, and so how can we convert these terms into the what? The time domain in here. First of all, writing ys and us like, if we multiply ys with the denominator and this one, this must be equals to each other, right? And so ys s square 3s 2, which is equals to the what? 5us, right? And so how can we convert this equation into the time domain? Burak. Yes, but we can automatically do that. This is the what? The second order derivative. Okay, and so this is must be equals to y dot dot plus 3s 3y dot plus 2y, which is equals to what? 5 ut, right? Or u. Okay, so if I write this equation just like this one in 3y dot dot, which is equals to the what? Minus 2y minus 3y dot plus 5u, right? These are the equation. And so, Pelin, how can we write the equation of motion right now? We just need to use the dummy variable, right? And so z1 is equals to what? Yes. z2? Yes. z1 dot z2 and z2 dot minus 2 z1 and minus 3 z2 and u, right? And so just writing the state space just like this one, z1 dot and z2 dot, which is equals to the what? To this term, and this is the z1 and z2 plus we have the 2 times 1 matrices in here, and so this is 2 2, and so what's the first term in here? z1 dot possess only z2 0 1, z2 dot minus 2 minus 3. What about the first term of the input matrices? 0 and 5. Yes, and so z dot a z plus b u, right? That's okay. Any question? Hı? Her şeyi anladınız mı arkadaşlar? Bakın bu her şeyin temeli bunlar. Yani bunun teorisi de bu, pratiği de bu, her şey de bu. Eğer bu soruları çözebiliyorsanız, yapabiliyorsanız geri kalan kısımlarda zaten çok zorlanmayacaksınız. O yüzden bugün böyle zaman cevabı ile alakalı en azından şöyle görelim. Zaten bir sonraki hafta time response'ı işleyeceğiz. We will study in time response related to these terms, especially for both the frequency and time domain. But this is the basis for the whole of these things related to this class, okay? Okay, and so in the third section, converting from SS to TF. The SS can be given by this one. X dot is equals to what? AX plus BU, right? And Y is the output equation CX DU, right? And so, if I take the Laplace transform or apply the Laplace transform of these terms, this is the first step. In the second step, we will get to this equation. This is the X dot, right? Even if it's a vector, we can apply the Laplace transform in here. And so, S times XS, which is equals to what? A XS plus B US, right? And so, YS, which is equals to what? C XS DUS, right? So, if we want to solve the XS in here, in the third place, solving XS yields to what? Just take this and put to left hand side of these terms, okay? And so, this is equals to what? S XS minus A XS is equals to what? B times US, right? If we collect these terms in here, this is equals to SI minus A XS, which is equals to what? BUS, right? What's the meaning of this I? Identity matrix, yes. And so, from here, XS is equals to what? SI minus A inverse times B times US, right? And so, in the fourth, if we put this XS into the YS equation, YS, which is equals to the what? C times SI minus A inverse B US plus D US. And so we can collect to the what? The US at the right hand side. And so YS, which is equals to the what? C times SI minus A minus 1 B plus D US, right? Huh? I don't know what you're saying. I don't understand. Okay. And so, what is the transfer function? TS YS US is equals to the what? C times SI minus A is 1 B plus D. This is to what? A procedure to convert from SS to TF. Okay? And so, if we have the n state space representation, and if you know the C, A, B, D, and so you can easily convert this form into the what? Transfer function. Okay? Any question? Any question? Okay, guys. If you don't have any question this week, let's begin and end.